So now let's talk about the domain of functions of several variables. So if I have my function of two variables, then the domain consists of ordered pairs x and y. So your domain is going to be contained in R2 in the xy plane. And then if I have a function w of three variables, then your domain consists of ordered triples x, y, and z. So for a function of three variables, your domain, it's contained in three-dimensional space. So we're going to look at some examples now where we're trying to find domain. So let's find the domain of each function. So the first function will be the square root of x squared plus y squared minus 9 over x. And so usually when you're looking for domains, I always ask myself, like, what can't I do, or what goes wrong here? Well, the first thing I see is I'm dividing, and you can't divide by one number. And what is that number? I can't divide by 0. So I need to make sure that the denominator is not 0. So I also see that I have a square root. And remember, you can't take the square root of a negative number. So I need to make sure that x squared plus y squared minus 9, that's greater than or equal to 0. So x squared plus y squared is greater than or equal to 9. So in this case, you can describe the domain D as the set of all points x, y, where x is not equal to 0 and x squared plus y squared is greater than or equal to 9. Now if we want to picture this domain, what I'm going to do is I'm going to take my inequality there, x squared plus y squared is greater than or equal to 9, and replace it with an equals to, right? And what's that the equation of? That's the equation of a circle of radius 3 that's centered at the origin. But my inequality was greater than, so it's all the greater than or equal to, so it's all the points that are on the circle or outside of the circle. So I can actually draw a picture representing the domain here. I have a circle of radius 3. Let's see if I can draw a decent circle here for you. Okay, so it's all the points that are either on the circle or outside, but remember I also had this condition that x couldn't be 0. So I've got to remove the y-axis from my description. So here I'm not going to include any points on the y-axis, and all the points outside of the circle or on the circle. So the domain, it also includes the circle as well, except for my points on the y-axis there are not included. So we can say the domain consists of all points that lie on or outside the circle x squared plus y squared equals 9, except points on the y-axis. Let's look at one more domain problem. Now we're going to switch to a function of 3 variables. So again, I have a dividing, so the denominator can't be 0, but in this case, the denominator is a square root. So we need to make sure that underneath the square root now, it can't be negative, but it also can't be 0 because it's in the denominator. So 9 minus x squared minus y squared minus z squared is greater than 0. So if I move all my minus terms over to the other side, and then I'd rather write the variables first, so I'm going to switch the order that these are written, but the mouth points to 9 on our inequality. So I can describe the domain. It's all the points x, y, z, where that vertical line means where x squared plus y squared plus z squared is less than 9. But let's look at this inequality again, and if I replace the less than with an equal to, I'm looking at the equation of what? This is the equation of a sphere of radius 3. It's centered at the origin. So my inequality, though, was less than, which means now I'm looking at all the points that are strictly inside of the sphere. So the domain consists of the points that lie inside a sphere of radius 3 centered at the origin.